Hey guys, what's up? Eddie Alho here with kissanalog.com. So today we're going to do a quick video on a current probe, and I wanted a current from my oscilloscope for audio stuff and for other testing. Did not want to spend $1,000. Didn't want to spend $500 even. So instead of buying the Tektronix, I bought a Hantek, and today we're going to do some quick measurements to show how it works, some kind of tips and tricks on how to get good measurements, and that goes along with pretty much any current probe, but played with this a little bit and just want to show you how it works and talk about it a little bit. Okay, so before we bring the camera over here, I'm going to just kind of briefly talk about a couple things. There's they make a series of them: 65 amp, 650 amp, 1100 amp. This is a 65 amp because I don't really plan on doing a lot of things more than 65 amps. It's got the BNC, so it plugs into my scope, not the banana. You can get that too. This one on Amazon was like $61, $62. That is pretty dang cheap. I didn't know what to expect. And to tell you the truth, I'm actually impressed. It has a nice feel, feels pretty solid. I mean, it doesn't feel like $1,000 probe because it's not, but it sure doesn't feel like a $62 probe either. Okay, so it has the off switch, right? 2 ranges, 1 millivolt per every 10 milliamps, and 1 millivolt for every 100 milliamps. The lower scale goes up to 2 amps, and the other scale goes from 2 amps to 65 amps. It does AC and DC, and it goes up to 20 kilohertz. Good for audio, like I say, and power supplies, inrush current, that type of stuff. This is gonna be a quick demonstration of this. Just by the way, it takes a 9-volt battery. I stuck that in here already. Has not a super long cord, which I'm glad, because I don't plan on reaching, very far. But if you already, it's nice not to, you can see how messy things get with a lot of cords, or length of cords. And if you did need a long cord, then you could always obviously get another BNC extension. I just noticed as I'm looking at this, there's a place to put a little ring. I guess if you're maybe it might just be part of the cord design, but I suspect if you got 2 or 3 of these in your circuit, you'd want to put little colored rings like you do on your scope probes. But anyway, it did not come with those. It came with the meter and an instruction guide with which it's just a simple, very simple guide. I suggest keeping it just so you can quickly look at your accuracy for your different current ranges and frequency ranges. It's nice that it gives you that that printout right there. All right, so let's get doing some measurements. Okay, so before I bring the camera a little closer, I just wanted to point out, besides the 3 ranges, it has a power LED, which is on a green LED. It's not super bright, which is great. It's not wearing down my 9-volt battery. And it has a low battery light, which I guess if you have this in one of the 2 positions other than off, and you're not getting one of those 2 LEDs, then the battery's probably just dead. So this little button right here in the corner, it's a degauss button, and I'll show you how to use that. Other than that, pretty simple, pretty basic. Okay, let's bring the camera over and show some close-ups and do some measurements and see what you think of this thing. Right now I'm going to tell you I like it. $62. Wow, I'm actually really impressed with that. So let's bring the camera over. This is the box. Hantek current clamp. There's one edge, there's the other edge, and here's the other edge. This is the variety you can get. Again, I have this one. That's what's checked off. So that's the current probe right there. That's the switches. Very positive clicks. I don't know if you can see the green LED, especially with all these lights on. And then here's the little degaussing button. Nice little spring in there. CC-65. Now here's one thing I want to show you. There's, I guess, the serial number or whatever, I don't know. Battery compartment. And this is the one with the BNC connector. Okay. Pretty simple, pretty basic. One thing I want to point out, whenever you get a current probe that does DC current, you'll find an arrow. Oh look, I have an arrow, but I drew that on there. It's not a great arrow, but it did in a pinch. I just wanted to remind myself. I took some measurements, found out which way it flowed, and I kept looking for an arrow somewhere, did not find it. So, I guess that's what you get when you buy a $1,000 probe. Well, that plus some accuracy maybe. But you know what? For the kind of work I'm going to do, I think this thing is going to work out great. So we'll demonstrate that and the type of testing we do. Here is the spec sheet. I'll zoom in, and you can see 20 kilohertz for AC, DC's up here, and up to 65 amps AC or DC, and 2% on some of the scales, up to 8% on the larger current scales, 1.5% on the low scale for DC. I think 2%, 4%, numbers I'm seeing here are going to be completely fine with what I'm doing. So again, very happy with $62 spent on this. $61.99, I think, to be exact. Okay, now let's look at the scope, and we're going to plug this in, take some measurements. I have, again, this load resistor. This load resistor's 4 ohms, 200 watt, non-inductive. Nice. See, I'm hooking my power supply up to it. So then what I'll do is I'll clamp this on. Now one thing I want to show you is you got to hit this degauss button. I'm going to show you on the scope. You want to hold this down for a moment to degauss at every and occasionally after taking some readings, you want to degauss it occasionally. Okay, so here, now let me move the camera so you can see the scope and my power supply. Okay, so what we're doing here is we've got our scope, we've got our power supply, and we've got the current probe plugged into channel 2. Hantek current probe plugged in channel 2, and I've moved this cursor down here at the bottom of the screen so we can get as much of the window. See, if I move this around, it shows 600 millivolts, minus 600, because we're down 3 divisions from the middle. That's 600, because it's 200 millivolts per division, so 2, 4, 600 millivolts down. So that's our 0 ref, and 200 millivolts per division. We're sitting at the minus 600 millivolt line, and and we're triggering on the edge, the rising edge. So okay, and we're DC triggered, DC coupled with our current probe. So okay, now the one thing you want to do before you get started is hold this button down. See, it kind of moves a little bit, the line here. So when you hold this down a little bit, let go, it doesn't move anymore, then it's degaussed. Okay, now I take this, now actually the current, let's see how it goes now. So the current actually goes into the face. I had this backwards before because my probe, when I was using it before, I had it invert on, so I actually had it backwards. So the current goes into the face from plus to minus that way. So I'm gonna have to draw an arrow on this. So anyway, it goes that way. See how the just popped up here, went 1, 2, 3, 4, 5, just a little more than 5 divisions up. It's 1 amp, so that's off a little bit. So I don't think that's. Let me degauss that again. I'm going to hold this down for a couple seconds, let go. Let's clamp on again. Okay, there we go. So it's just barely over the line, it looks like. This is 1 amp. I'm going to turn on my measurements. Well, now one thing, this says 200 millivolts per division, and I'm on the 1 millivolt per 10 milliamp scale. The 1 by 10 is a 10x. So I want to put my probe at 10x where I have it. That way it's a 1-for-1 on the scope. But I want to say milliamps instead of millivolts. So go to channel 2, channel 2, and page 2, and units are volts. Let's change that to amps. Okay, now it's amps. So now it's 200 milliamps per division. So now I get a 1-for-1 on the scope here. But I'm going to set the measurement too. So go to measurement, type, and I think what we want to do is do maximum. I'm going to do RMS too, just for fun. Sorry, you probably can't see what I'm doing. There's RMS, I just pushed a button. So I've got RMS and maximum selected. See that? Okay, now just push this, that window goes away. And now I have maximum is 1.04 amps. RMS is 1.02. Let's zoom in, see if you can see that a little close. Uh-oh, sorry. Let me zoom in on that, see if you can see that better. Okay. There's maximum. Camera's bouncing. Okay, there's maximum 104 and RMS 102. Looks pretty darn close. Zoom out. Whoops, zoom out here. I'll rotate over here so you can see both things. Now if I set this to half an amp, we'll see, watch that drop. So current 0.5, enter. Half an amp, and now look at that. 1, 2, it should be, well, I guess that's right. So is that right? 200 millivolts per 2, 4, and it's half the division, so yeah, that's correct. And right down here it says 536 and 509. Zoom in on that again for you. Okay. Now, just to, kind of keep pushing this idea about degaussing, you don't want to do it when current's flowing through, so disconnect it. And look, it went down to the 0, so I think it looks pretty good. But if I just hold that down for a few seconds, then take that again. Oops, sorry. Go in the right direction here. Okay, so it's about 536 milliamps, it's saying. If I take this off, yeah, you got a $1,500 current probe. You do this one time and it does a pretty good job. This guy, if you really want high accuracy, it says 536 again, so I don't know, it's thinking the current's a bit higher. Okay, so let's drop down to 100 milliamps and see what kind of resolution we get. Whoops, let me get this set 0.1. Let's try that again. Set 0.1. Okay, 100 milliamps, 0.1 amps. Now let's change the division here so we can get better accuracy. Now it looks kind of noisy there. Now that looks like it's at 0, but I'm going to degauss it anyway. Okay, now clamp back on. And I'm getting about 94 or 95 milliamps, 83. It's kind of bouncing around. Here, I'll zoom in on this. If you can see that. Looks a little noisy. Oops. Yeah, it looks just a little noisy. Okay. But that 100 milliamps, I mean, if you want to go down that low, it'll go left. It'll even go lower. Here, let's go. It says 10 milliamps. I'm going to go down to 50 milliamps, 0.05. There we go. It's saying 47, 33 over here. I don't know. Let's see. Let's get some more scales here. It's kind of off the screen. Okay, I'm going to pull this off and degauss. Sometimes when you change ranges, see how it's below the line here? Now if I hold this down, see how it comes up? When I let go, it should stay there. That's when you know that you got degauss. Okay, get this back on there properly. Wow, this is really sensitive. When I put it down close to my other instruments, it moves around. So if I hold this up, I'm seeing about 58 milliamps. So, you know, that's pretty darn sensitive. That just shows you when you're taking, you know, measurements with, you know, these more sensitive measurements, you want to move your wires away from around other wires that might be carrying current. But, okay, so that looks pretty good. Now, let me jump up to 2 amps. I'm going to go to 1.9 amps just so it's below the range, the max. Current 1.9. Now, you know what? Let's bring this down. And I'm going to put this on single trigger. Okay, and I'll bring the trigger level up. And let's see if we can capture this guy as I hit the button. Let's see if that works. I should try this before okay, got to enter it here. Whoops. Yeah, sorry about that. I didn't set the scale right. Okay. Okay, let's degauss this guy. I'm at 1 amp per division. Let's do... Okay, let's set this for 0.5. Let's try this. Let's try to capture a step in current from, like, say 0.1 amp to 1.9 amps, okay? So let's do that. So what I'm going to need to do is, here, let me see. I'm going to have to set up my instruments here. Okay, the volts. If I'm going to put 2 amps or so into my resistor, I'm going to need 8 volts here or more. So I'm going to set the voltage to 10 volts. It'll try to go to 10. Okay, now when I click on my meter, now the you know, the current that I set this to is going to limit the voltage because of the 4 ohms. So that's 1.9 roughly. Okay, now let's set up this guy to single trigger. Now put my current clamp on here. I'm going to degauss it first. Okay, now I'm going to stick on here and let's see, set the single up again. Now that, okay, now I'm going to turn the power supply on. And where is it? I keep on putting the current, okay. Alright, let's try something. We're going to do a step in current from 0.1 amps to 1.9 amps. Okay, I had to set my voltage. I'm going to disconnect my resistor here. So I set my voltage to 10 volts. When I connect up my resistor, I have the current set to 1.9, so in 4 ohms it drops down to 8 volts. That way I know I can push as much current as the resistor will let me. Okay, now I'm going to connect this probe up. Alright, so it's saying, yeah, 1.96 amps. Okay, current's coming into the meter this way, 1.96 amps. Okay, now what I want to do is I'm going to set this current down 0.1 and then actually I'm going to just turn it off. Let's just do that. I'm going to go from 0 to on. So let's turn off the output, set the single trigger, and let's turn this on, see if we capture a... Wow, okay, I'm going to have to change this time scale. I was set at 200 microseconds per division. Let's go, that looks like about the right curve, 2 milliseconds per division. Okay, turn this off again and put that on single. Okay, now let's try it again. Turn that on. Oh, look at that. So that's 1, 2, 3, 4 divisions at 2 milliseconds per division, so that's 8 milliseconds. Now I could use a scope to do the measurements for rise time and all that kind of stuff, but yeah, so 8 milliseconds. That's how fast this power supply turns on. It kind of has a ramp, it looks like. So let's try this. If I disconnect this current from here, drop down to 0, we're going to set this to single, and we're going to see how this makes it different. I want to show, this is also a good example of power supply testing. When you want an inrush current, don't turn your power supply on, do it this way. Watch. Look how fast that is. That's very fast. It's just a super fast edge. So let's zoom in. Okay. Okay, look at that. I spread out the time, and I could have done it that way. I said zoom before, right? Let's go backwards. See, when I go here, how it stops, I know I'm not where my original setting was. Now it's going to the edges of the scope. That's my original settings. So I can push this button in, and there's a little sliver right there. I'm only seeing part, so let's open it up a little bit. And you can see how I'm spreading out the time. So it looks pretty darn fast. This is 2 milliseconds per division up here. 2 milliseconds per division. This little zoom, the Z, shows 10 microseconds per division. And I can line this thing up with the center if I want. If I move it the right direction. And now it's easier to count. 1, 2, 3, maybe 4 divisions. I'm almost up there. 40 microseconds. Pretty fast. 40 microseconds, pretty darn fast for this current meter to capture that. That's pretty cool. Alright, well, there's how you can set up your scope to read your current with this current meter for 62 bucks. There's how you can read inrush current from a power supply. So, just a quick example. We'll have much more testing with this days to come. But I was kind of excited about this. I just wanted to do a quick video to share this. Hantek, pretty impressed. Hantek working with my Signet. They work, you know, BNCs, so many millivolts or milliamps per volt. It doesn't really matter what scope you have it hooked up to, right? So the Hantek likes my Signet. All right, hey, thanks for watching, guys. Give me a thumbs up if you like that video, okay? Thanks, guys.